Hello, students, and welcome to our next topic in science this year. We are all going to become lunatics this week about science because we are discussing the moon, and more specifically, this topic is called lunar cycles because it's not just the moon we're focusing on today, but we are going to be focusing on really how the moon affects us here on Earth. But we will begin with the moon as we talk a little bit about that nearest neighbor of ours in space. In fact, it is the only place in the universe other than planet Earth that human beings have ever visited. That's right. And we haven't even been there in about 50 years, although there is talk that in the year 2024, human beings may return to the surface of the moon aboard the Artemis project, and the first woman hopefully will set foot on the moon as well. But human beings, there are only 12 human beings who have ever set foot on the moon, and the last one was Gene Cernan in 1972. We haven't been there since. In fact, we haven't even been anywhere close to it. You may hear about people going into space frequently, especially now with commercialism in space. But these folks are barely leaving the Earth's surface. The moon, on the other hand, is 250,000 miles away from planet Earth. And again, we haven't been there in 50 years. But let's talk a little bit about the moon and our observations of it, beginning hundreds of years ago with a scientist by the name of Galileo, 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 Galilei. Galileo. Galileo back in 1609. In fact, I think that was the same year Jamestown was settled, if I recall correctly. That was a long time ago. 500 years ago, over 500 years ago. Galileo was the very first human being ever to see the moon through a telescope. Now, ever since human beings have been on planet Earth, we've seen the moon. You just have to open up your eyes and you'll see the moon, especially when it's a full moon at night. You can't miss it. But Galileo was the first one to view it through a telescope. And that observation led him to some very interesting conclusions, not the least of which is the fact that the moon is a sphere. It's a three-dimensional circle, not a disk. It's not flat. It has curvature to it. In fact, he observed a number of different features on the moon, such as its topography. Now, there's a word that's familiar to you from previous topics. Topography, as we know here on Earth, is the shape of the Earth. Well, there is a topography on the moon as well. The moon is not flat. The moon is not smooth. It has ups and downs and bumps and grooves. It's a very dynamic surface, and we know that now from firsthand experience with the 12 astronauts that have actually walked around and driven around on the moon. But Galileo was the first one to see the topography of the moon through his telescope. And so let's go over a few words here regarding the topography of the moon, beginning with Maria. Maria or Maria. More appropriately, this is pronounced Maria. Maria is the plural form of the singular mare, which is a Latin word that means sea. When you look up at the moon, depending upon its phase, if you're looking up at the full moon, you may see these large, darker areas on the surface of the moon. Many years ago, people believed that these dark areas were actually oceans or seas of water on the moon. We know today that that is not the case. The moon is a very dry body in space, although we have discovered recently there is frozen water ice near the south pole of the moon, and that's where I believe the Artemis program is going to be landing. But the seas or the mare on the moon are dry, barren plains. They are flatlands, basically. So, despite the name Maria, they are not wet at all. Next, we have the highlands. We here in New Jersey, in the northwestern part of our state, we live in the highlands of physiographic province. And all that means is that we live in an area where there are lots of hills. Well, the highlands on the moon are the mountains on the moon. And there are mountains on the moon that are higher than northwestern New Jersey. But these areas are typically found in the lighter colored regions of the moon. Again, the darker areas are the mare or the seas, dry seas on the moon, the flatlands. And the highlands tend to be the lighter colored areas when you look up at the moon. Now, probably the most distinctive feature on the moon, and you can see these features even with weak binoculars, much less a telescope. In fact, the telescope that Galileo used was no more powerful than a good pair of binoculars today. And we can see these features called craters. Craters vary in size from microscopic, itty bitty little things to hundreds of kilometers across. And there are some really famous craters on the moon, like this one is called Tycho. It's got a really cool center. It almost looks like the Death Star on Star Wars. Boom, boom, boom. But here's the deal: craters come from two different origins, you might say. Most of the craters on the moon have arisen from meteor impacts. In other words, these large objects that we'll learn more about in later studies in the fourth unit when we talk about astronomy, we'll be learning about meteors. But meteors, these big chunks of rocks, they're traveling at many thousands of kilometers per hour. Sometimes objects like the moon or the Earth get in the way of their path of travel. And if we happen to be in the way, or the moon happens to be in their way, these meteors will just smash into the surface of the object, in this case the moon, and will form a crater. But some of the craters on the moon actually go way back into the past history of the moon's surface, because it is believed that long, long ago, the moon experienced volcanic activity. And some of the craters on the moon are actually old volcanoes. And the insides of these volcanoes include these plains, these maria that we talked about earlier, that are flat volcanic plains. So again, craters, most distinctive feature of the moon. Most of them are from meteor impacts, some of them from volcanic activity. Now, as far as craters are concerned, there's a difference between the near side and the far side of the moon. One thing you're going to be learning about this week is the fact that the moon's orbit around the Earth is very interesting. The same side of the moon always faces the Earth. So no matter what phase of the moon we're looking at, we'll get into phases of the moon later on, but no matter what phase of the moon we are gazing up at the sky and observing, it's the same side of the moon that's always facing us. So there's a near side to the moon and there is a far side to the moon. The far side of the moon is not always the dark side of the moon, because as we will see, as the moon orbits Earth, all of the moon is illuminated at one point or another throughout a lunar month, which is the same as a lunar day. But we'll get back to that. But here's the deal. One side of the moon always faces the Earth. The other side always faces away from the Earth. And if you look at these two pictures, here is the side of the moon that always faces the Earth. Here's the side of the moon that always faces away from the Earth. And if we look at the distribution of craters, you can see by these pictures that the far side of the moon has a lot more craters on it than the near side. And there's a reason for that. And the reason, very simply, is the Earth, over the history of the Earth and the moon's relationship with one another, the Earth has protected the moon. And conversely, the moon has protected the Earth from a lot of meteor impacts. Because the moon and the Earth are relatively close together, any meteors that might be flying through space are going to hit the first object first before they hit the second object. So if this is the moon and this is the Earth, and the meteors are coming in this direction, they're going to hit the moon first before they get over to the Earth. I think I said that right, which means the far side of the moon is going to sustain a lot more damage than the near side, because the near side is somewhat protected by the Earth. So we'll see that in class as we play around with some models of the moon-Earth system, but I think you get the idea for now. Most of the craters are on the far side of the moon. But there are other features on the moon as well. In fact, we visited one of these, humans visited one of these, a very famous one called Hadley Rill. We'll get to that in a moment, but a rill. A rill is a long valley on the moon's surface due to past volcanic activity. Here's a photograph of the moon's surface, and you can see this feature right here is called a rill. This is a rill. So it's a long valley on the moon's surface due to past volcanic activity. And here is a closer up shot of the Hadley Rill, which was visited by the astronauts on the Apollo 15 mission. And again, this was in the early 1970s that humans visited the moon. And there were only Apollo 16 was the last mission to go to the moon. So this was the second to last mission to the moon, Apollo 15. And here we can see astronauts on a moon buggy driving around. And here's a shot of where they landed on the moon, and they explored Hadley Rill in person. Fascinating time. The Apollo moon missions were absolutely phenomenal. But we'll talk more about those when we get to astronomy later in the year. All right, so there are some features of the moon. Now I want to talk briefly about some of the movement of the moon relative to the Earth, because it's really the movement of the moon that has the greatest impact on us here on planet Earth and the entire planet for that matter. So the moon orbits the Earth in what's called an elliptical orbit. What does that mean? Well, if you look at the shape here of the circle, and we're pretending that this is the Earth and this is the moon. And this is the pathway that the moon travels around the Earth. Now, this is highly exaggerated, but it makes the point. An elliptical orbit is like a squished circle. In other words, there are some times when the moon is closer to the Earth, and there are some times when the moon is further away from the Earth. And by the way, the same is true of the Earth going around the sun. Sometimes we're closer, sometimes we're farther away. So, what are these two times called? Well, when the moon is at its closest point to the Earth, we call that perigee. Perigee is the time in the moon's orbit when the distance between the moon and the earth is at its shortest distance. Over time, you probably hear on social media people talking about the super moon. A super moon is really not that super. It happens every month pretty much, but the point at which the moon is at its closest point to the earth, if that coincides with a full moon, people call it a super moon. We just love attaching special names to things, but it just has to do with a full moon during perigee, or the closest point to the earth. We can contrast that with what's called apogee. Apogee is the point in the moon's orbit when the moon is farthest away from the earth. So this does affect things that happen on planet Earth, not just our viewing of the moon, but it affects the tides and, well, other things as well. But right now, perigee is the closest point. Apogee is when it's farthest away. What the way that I remember which one is which, I think of the word apogee. Apogee starts with the letter A, and that is when the moon is farthest away from the earth. That's the way I remember it. So apogee, away, farthest away. Now, period of rotation. What in the world is this talking about? Well, let's review the period of rotation here, and we may even finish with this part here today. The period of rotation is the time it takes the moon, or any celestial body, including Earth for that matter, but it is the time it takes to rotate on its axis. On Earth, our period of rotation, or the time it takes Earth to spin once on its axis, I wonder if you know how long that is. How long does it take the Earth to spin once on its axis? Hopefully, you were thinking one day. A day on planet Earth is the time it takes for Earth to rotate once on its axis. It's 24-hour period of time. All right, so the period of rotation on the moon, however, takes a little longer. In fact, before we get to the exact period of rotation, let me just mention this other term, the period of revolution. The period of revolution of a celestial body is the time it takes to orbit around another body. In the case of the moon, it's the time it takes to orbit or revolve around the Earth, because the moon revolves around the Earth. In the case of the Earth, the period of revolution is the time it takes to orbit or revolve around the sun. And I wonder, do any of you know how long it takes the Earth to revolve or orbit around the sun once? Hopefully, you said 1 year, because it takes 1 year for the Earth to go around the sun. But the moon is different. The moon is different. The moon rotates on its axis, and the moon revolves around the Earth. And this is very unique, because in the case of the moon, the period of rotation and the period of revolution is the same. They are both about 29 and a half Earth days. In other words, if you lived on the moon and your frame of reference was the surface of the moon, 1 day on the moon would be equal to 1 month on Earth. And 1 year on the moon would also be equal to 1 month on Earth, because the period of rotation is equal to the period of revolution. And it is this interesting fact about the moon that enables the same side of the moon always to be facing the Earth. It's a very unique and interesting fact that is probably pretty darn unique in the course of in our solar system, at least. I don't believe any other natural satellites of other planets experience the same condition as the Earth's moon. So there we have it. We've got the various features of the moon and how the moon moves around planet Earth. I may show you another quick little video clip here illustrating this from the vantage point of space. And that'll be it for today, because tomorrow we're going to focus on the phases of the moon and how the phases of the moon impact other things on Earth, including our oceans. So stay tuned until tomorrow for more information about the moon. But for now, I'm going to say bye bye.